Looking for differences between two groups is called means comparison and forms the basis for hypothesis testing in experiments. It can also be used to compare nominal, that is, categorical, independent variables in surveys or content analysis. In experiments, the groups can be different. For example, a treatment and a control group where the independent variable, that is, a stimulus, is manipulated in equivalent groups of randomly assigned participants. The treatment group has the stimulus and the control group does not. Another type of means comparison takes place between measurements of the same group at different times to see if there is a before and after effect with regard to the stimulus or independent variable. A third comparison, much more rarely used, is a one-sample comparison where the sample mean is compared to the known population mean to assess the representativeness of the sample. Regardless of the comparison, hypothesis testing is used to support the finding that the group means really are different. By really are different, researchers typically assume being correct at least 95% of the time. This is expressed as a probability, P, that a group difference is correctly claimed. In the case of an acceptable claim of group difference, the statistic chosen is said to be P is less than 0.05 or less than a 5% chance of a false positive. A false positive, that is, finding a difference that's not there, is called type 1 error. False negatives, that is, not finding a difference when there really is one, are called type 2 error. Correct claims are bolstered by rejecting a claim that is suspected to be false. The so-called null hypothesis states the means do not differ in reality. This reads null hypothesis, the population mean, mu1, is equal to the population mean of group 2. By rejecting the null hypothesis, that is, no difference in the group means, when the null is indeed false, or failing to reject the null when it is indeed true, we make a correct decision. The null hypothesis is akin to assumed innocence in a jury trial. By rejecting the null that is truly the case, it's a type 1 error, like declaring a guilty person innocent. With only two means to compare, you use the t-test. T stands for 2. The one-sample t-test is so rarely used, let's skip over it. The independent samples t-test is for comparing different groups, and the paired sample t-test is for comparing the same group before and after the stimulus. SPSS makes short work of such comparisons. Before we look at both, remember that parametric hypothesis testing has 4 assumptions. There are separate SPS tests you can run to test these assumptions, but you can ignore them for now and in your class project. The independent sample t-test needs to identify the groups. This is a separate value in SPSS coded 1 or 2. The degrees of freedom are the total sample size minus 2 because there are 2 groups being measured. Here's an example with 52 cases. There are 24 variables. We're going to be looking at attitude, and then our group variable will be the experimental assignment variable called FAL-XPIR in this particular data set. Looking at the different columns in the data view, you see we have 52 cases. To run a t-test for independent samples, click Analyze. This is a means comparison test, so we compare means and choose independent samples t-test. The grouping variable is FAL-EXPER. I think it was a fallacy experiment. That's why it has this name. And we have to define the groups. Most of the time they're labeled 1 and 2. And then we need a test variable. The test variable in this example is called attitude. Click on OK and we have our output. The output might seem confusing at first, but let's take it into 3 sections. First, we have the means of the 2 groups. For the 23 people in group 1, the mean value was 19.87 when rounded, and the standard deviation was 6.02. For the 29 people in group 2, the mean was 22.38 when rounded, and the standard deviation is 3.90 when rounded. We look for equality of variances, one of the assumptions. Levene's test assumes that there are variances. The only way you would see that there were not variances is if the value under sig, which is equivalent to p is less than, if it was less than 0.05, which it is not, it's 0.06. The final section of the t-test reveals the value of t. In this case, it's negative 1.82 when rounded. Had Levene's test been significant, we would have used the lower value, 1.73. The degrees of freedom, when the equal variances are assumed, is 50. That's because we started with 52 people, and you subtract 1 for each group you use. The significance of the test is 0.075, which is not less than 0.05. So this tells you what p is equal to. In this case, we would not find a significant difference between the two groups. The paired sample t-test treats the two groups as two sets of values in SPSS. The degrees of freedom are the sample size minus 1 because there is only one group being measured. Here's an example with 19 cases. The values, the variables are labeled pre-test and post-test. Here's what it looks like in the variable view. To test this, we go to Analyze. It's another means comparison. We click on Compare Means, and then Paired Samples t-test. Much less information to enter. Our pre-test is variable 1, and our post-test is variable 2. Click on OK, and the output appears a little easier to understand this time. We see the differences between the two groups. Before the stimulus was manipulated, the mean was 13.21 for the 19 people. After the stimulus was manipulated, the mean was 14.58. Down at the bottom, we see a value for t, which is negative 0.371. The degrees of freedom is 18 because we subtracted 1 for the one group off the original sample size of 19. In this case, p is equal to 0.002, which is definitely under 0.05. In fact, we could report this as p is less than 0.01. APA style requires that you report the exact value of p. In cases where it's 0.00 something, you do not round to the nearest hundredths place, but you do not round beyond the thousandths place of the decimal. That concludes our look at group means and mean comparisons. See you next time.